Here we go. My bad on the typo on the other one. That last section was 8.3. This is really 8.4. Please forgive me. Okay, we are talking about trig functions today. Trigonometry, or trig, study of triangles. So when we talk about this stuff, there's definitions you gotta get down. And before anybody starts freaking out, fretting, oh, we're doing trig, it all boils down to the same stuff. Are you memorizing things? Can you memorize things? And we'll see. So there are three trig functions. Sine, which we abbreviate SIN. Cosine, which we abbreviate COS. And tangent, abbreviated TAN. And yes, these are on your calculator as well. We're talking about exact answers at the present moment. So here's your definitions. We say sine, we mean the sine of an angle equals opposite side over hypotenuse. So it's a ratio, plain and simple. It is a ratio. What are these talking about? A right triangle. Cosine, adjacent side over hypotenuse. Talk about what that is in 1 second. Let's get this third definition. Tangent, and again we'll say tangent of an angle equals cosine of an angle equals. So in other words, you'll have an angle measure dealing with this, and it will come out to the ratio of these sides. This is equal to opposite side over adjacent side. So once we get familiar with it, we'll find out that we'll just say opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. You're used to saying that right now. So as we talk about these things, there's something going to be called a reference angle. A reference angle, if you're ready for it, is the angle we're referring to. Since I don't want to use its own definition, a word in its own definition, it's going to be the angle being used. So here's what I'm talking about. Let's say we have this right triangle, A, B, C. And we're going to say that A is our reference angle. So I'm going to circle it. New to this stuff, you want to be real basic with everything you're doing. So if A is our reference angle, here's what we're talking about. This would be little a. This would be little b in this case, and that would be little c if you want to do it that way. Typically those will be switched. So let's do that the right way. Let's do this right. A, B, C. So now you're going to fall into play. Little a, little b, little c. Hypotenuse is c. Still going to use an A as my reference angle. So here's what we're saying. I'm going to apply this to this right here. So sine. So if I wanted the sine of angle A, so it'll be sine, then the angle, you'll have measures here eventually, equals opposite side. What's opposite that? Little a. Over hypotenuse, C. Cosine of angle A. Adjacent. So what's adjacent? Touching. So it'll be B over C. Tangent of angle A says opposite, so that's opposite of it, over adjacent. A over B. And again, what's this talking about? This angle measure, however many degrees it is, will be equivalent or matches the ratio of this length to this length. So whatever that would happen to be, they match up. Used to be charts in the back of books. Now it's all done with your calculator. But they match up with that. That's what we're talking about. So let's say, just for purposes, for whatever, let's say this is 3, this is 4, this is 5, there's angle A, there's angle B, there's angle C. So if I had this one here, let's use this as my example. Let's go angle B, let's go A, and then we'll do both. We'll see, show how it works for you. So if we wanted the sine of angle A, in this example, we would say opposite over hypotenuse. 3/5, easy decimal to figure out. The cosine of angle A is going to equal adjacent hypotenuse. 4/5. Tangent of angle A, by definition, opposite over adjacent. What's opposite? What's adjacent? 3/4. So in this particular example, that ratio would equal or be equivalent to whatever angle of measure that is. Again, not worrying about that yet. So same one though. What if I asked you for the sine of angle B? So the sine of angle B, opposite over adjacent, 4/5. Cosine of angle B, adjacent over hypotenuse. Tangent angle B, well, opposite over adjacent. Yes, you can see, at least I hope you're starting to pick up, these are complementary angles. Notice what's going on here. Okay, so let's put this to practice here a little bit for us. Let's say in this example, we've got our right triangle, C, B, A. This is 6, and this is 20. We want to find the measure of angle A. All right, so we look. What do we have in relationship? Reference angle. What's in relationship to it? This 6. It's the opposite leg. We have this 20, which is the adjacent leg. So which trig function deals with opposite and adjacent? Tangent. So as I set this up, we'll say the tangent of angle A is equal to opposite over adjacent. And then we'll use this to help figure out the angle measure. So put that on hold. We'll talk about how to use a calculator to do that here in 1 second. Let's work about on finding a side as well. So look at the difference here in the two. Here we had two sides, had to find an angle. Okay, I'll come back to that, please. Going to this one though, let's say I have an angle, and I'll show you how this all comes into play now. And I got to find that side right there, and let's say I got that. Okay, same deal. I want to find this. How is it in relationship to this angle? It's opposite. What is this? Hypotenuse. What deals with opposite and hypotenuse? The sine function does. So we'll take sine of 25 equals opposite y over 5. I told you already, it's a ratio. So how do I do this? Well, we'll bring out our handy dandy calculator to help us out here. There's our ratio. how the cross product's going to work. Well, we're going to go here and get y, and then our calculator is going to help us figure this out. So clear, one thing, make sure your calculators are in degrees. That's with your DRG button, you can change them right here. I'm in degrees already, so I'm going to hit enter and make sure I do it right. So I want the sine of 25. So on my calculator, I hit sine 25. Good practice, close the parentheses. I'll hit equals right now. There's the ratio of that angle. Okay, this angle is equal to that ratio. Well, we're going to do a little bit to it. So I got to solve for y, so I'm going to take it times 5. So that's telling us that we get an answer of 2.1. So y is equal to 2.1. Or, yeah, we'll go to the nearest tenth on this one. So there's my ratio. Opposite hypotenuse, that's sine. Opposite and hypotenuse is sine. 25-degree angle, okay? Sine of 25 was that decimal we already had. But look at the ratio it's set up. How do you solve them? Got to use a calculator. Gives me that decimal times 5. So that's about, if that's 5 feet long, that's 2.1 feet, or whatever you have. Let's try one more of these. So let's go with x. Let's go 70 degrees right there. And let's go 15 right there. So again, recognize what you have. All right? Hypotenuse. Adjacent. There's my reference angle. So this is a cosine problem. All right? How do we solve a cosine problem? Cosine of our reference angle, 70, equals adjacent, 15, over hypotenuse, x. All right, it's ratio time, my friends. But now look, before you do this, because that's going to give you, well, let's look. Before you get all crazy nuts on me here, cosine of 70 is this decimal, and it doesn't end there. It keeps on going. So we've had this discussion before. Am I just going to stop right here? Maybe. But you got technology. Why would you bother? So let's see how this works. Cross products here and here. So this times this, that means I got the cosine of 70, this crazy decimal right here, times x equals 15. Well, how are you going to get x by itself? Divided by the cosine of 70. What you do to one side, so x cancels out. So now, again, use your calculator. 15 divided by cosine 70. And again, I'm just in good practice. Enter. About 43.9 units. Whatever that happens to be. We'll come back to this one. I'm going to just give you these two. I got ahead of myself. We'll come back to that one tomorrow's lesson.